In this video, we're going to talk about temperatures and state of matter. In this column, we have our temperatures listed in units of Kelvin. In the middle column, we have our description. And in the right column, we have our state of matter and the motions. Let's start out at a very cold temperature. We're down here at about 0 Kelvin. At 0 Kelvin, ideally, there is no particle motion at all. So if we look at something that's 1 Kelvin, just slightly above no motion or no particle motion, then what we're looking at is a molecular solid. And in this molecular solid, we have just very, very small vibrations in these bound molecules. For example, let's say we're looking at a water molecule. Well, at a temperature of 250 Kelvin, we have this water molecule in a solid state. And at a temperature of 250 Kelvin, this water molecule in, say, a water ice cube has a larger vibration in the bound water molecule than at a cooler temperature, which has a smaller vibration. As you raise the temperature up to 350 Kelvin, you're going to break down this molecular solid and you're going to generate a molecular liquid. Now, the molecular liquid is going to be liquid water. Now, the molecules will still be vibrating, but now they'll be sliding past one another and they'll be rolling around as well. If you raise the temperature up to, let's say, 500 Kelvin, you're still going to have a molecule, but it's going to be a molecular water vapor gas. So now you have this water vapor, such as a steel kettle of boiling water. It's generating this water vapor gas. Now you have these collisions of these molecules when you're in this molecular water vapor gas state. If you raise the temperature up even more, let's say to about 3000 Kelvin, you're going to break down this water molecule into hydrogen and helium atomic gas. And these atomic gas particles are going to collide together. For example, we have a tungsten kettle of boiling hydrogen and helium gas. Those atoms are going to be colliding into one another. We have larger motions as you raise the temperature. If we raise the temperature to about 100,000 Kelvin, we are starting to get into a very low plasma state. So we have a low to moderate plasma state. We have some excited atoms and we have few ion collisions. So what we have here is, let's say we have some of these hydrogen atoms and some of the atoms are with the electron in an excited state. And some of the hydrogen atoms have the electron completely removed, so it's now an ion. Same thing with the helium. We have the electrons moved up into an excited state, or possibly one electron may be removed. Rarely would both electrons be removed to create a completely ionized atom. So we have this low to moderate plasma state. As you raise the temperature up to about 1,000,000 Kelvin, well, now you've got what's a high plasma state. So you have lots of electrons that have been ionized from their hydrogen and helium atoms. And so those electrons are moving around with higher speeds and we have higher speed collisions. So we have this electron sea and mostly hydrogen and helium ions. In this temperature, we have very little that is going to be in the excited atomic state. Most of the atoms are going to be ionized. So as you can see, we raise the temperature up, you're going to have more motions and you're going to break down the solid into a liquid. You break the liquid down into a gas. You break the gas down into a plasma state where you have more and more electrons running free in an electron sea.